If you can hear me, we're going to get started in just a minute here. All right, folks, sorry about the delay today. Just had to take a minute to get everything set up. Cool. I'll just do these. Oops. Minor edit here. I'm just being a little OCD because that's what I feel like doing. Okay. All right. So let's do a little recap about what we talked about last time, and then we're going to jump into talking about lists more today. Understanding and working with lists. We also, I'm going to kind of recap the recap because that's kind of where we're at with Premium Prep. So if you're in Premium Prep, this is pretty close to where we're going to be talking. Oh, looks like we already got a question. So this is, it seems like somebody wants to go over how to use elif, and like that you saw a function where there's some conditional checking, like if and elif at the beginning of a function, and you're wondering where you, and I apologize if I'm misinterpreting that question, but that's what I'm assuming you're asking. You can, if that's not what you're asking, feel free to clarify that, and I'll answer that question as well. So there's something called handling edge cases, and you usually handle edge cases first. So let's do a little example of this. So def has edge cases. I can't actually think of a problem with edge cases off the top of my head, of course. So let's say x x is supposed to be a number, so we might say we want this code to return. Oh, I can think of a. Sorry, this is a way better example. I can think of one that has edge cases. Let's do an isPrime function. So isPrime is going to take in a number, and it's going to return true or false based on whether that number is prime or not, right? So let's follow a workflow with this. So I have my definition. I'm going to put in my invocation before I start writing any code to fill this out. isPrime. Actually, and let's call this with a few different numbers. So let's do for I in range 15. So we'll do 0 to 15. And we'll pass my highlighting here. So this is how I'm invoking the function in order to test it. We have this for loop that's going to pull out every number in the range from 0 to 15, up to 15, but not including 15, so it's going to go from 0 to 14. It's going to represent each of those numbers successively in order as I. So in the body of this for loop, I'm calling the function that I'm writing, and I'm passing that I. So first I will be 0, then it'll be 1, then it'll be 2, then it'll be 3, right? Okay, so what we're after here is understanding edge cases. So I'm going to be a little bit flippant with the logic for this function, but in short, what we want to do in order to tell something's prime, we can kind of brute force it, and we can just divide that number by every number from 2, starting at 2 up to that number. And if at any point the remainder of that division, we're going to use modulo for that, the remainder of that operation is 0. If at any point the remainder of that operation is 0, then we know that we found a factor, a whole number factor to our n, which we're inquiring about, and we know the number is not prime. So in order to do that, I'm just going to do for divisor in range n over, well, we'll do range n. So I want to start at 2 and I want to go up to n. And we can shorten this range a little bit, but I'm not worried about like optimizing this right now in any way. So for divisor in range n, we'll see if n, we say if the remainder of n over divisor, so since we're doing a remainder, we're going to use modulo n over divisor. Oops. If n over divisor has a remainder of 0, so, or this is more like saying if the remainder of n over divisor is equal to 0, then we know divisor is a factor of n, right? So we can just return false. We know that number is not a prime number. Otherwise, we can just return true. And to the question asker, please confirm if I got your question correct, if I'm actually answering the question that you intended to ask. I'm hoping that I interpreted that correctly, as I stated before. And I know we're going a little off the rails here, but cool. Okay, so we have like the bulk of our logic. We have to start this range at 2, doing n over 0, which if you were in premium prep yesterday, or yeah, I guess it was yesterday, we learned about the 0 division error. So if I try to do like 3 over 0 anywhere in the code. I don't even need to print it out or assign it to a variable or anything. If I try to do it anywhere, Python is going to give me an error just for that. So it's going to say 0 division error, can't divide by 0. Cool, thanks for confirming 0, right? We can't just assume 0 like we normally. Number is a number that has no factors other than 1 and itself, because every number has 1 is a factor of every whole number, like by definition. Like that's the definition of a whole number, right? So we can't start it at 1, so we have to start it at 2. If it's divisible by 2, we know the number is actually even, so we can just skip that. Okay, so you may notice there are some situations here, and especially here, where our number will return the wrong thing, right? So if we pass the number 0 or the number 1 or the number 2, and let's actually just try those 3. So we're going to do 0, 1, and 2. So we'll do range 3 because that'll go up to 3 but not include 3. So we're just going to do those first 3. And we want 0, 1, and 2 to all not, or excuse me, 0 and 1 to all not be prime numbers. Anything less than 2, essentially. Okay, so this tells us that, here, actually, let me include I in here so we can, I'll just do this in an F string. Okay, so we'll say, so this says 0 is prime, true, 1 is prime, true, and 2 is prime, true, right? So we have this code. None of these are actually running in this for loop at all, right? Since our range is essentially 2 to 0 or 2 to 1, you have an inverted range in a way, so it's not going to count backwards. It's going to just not do what you want it to do. What we want is to handle these numbers in a special case. Since the bulk of our logic that's going to work for all of the other numbers is not going to work for just a couple numbers, we have an edge case in this function. So by convention, I think, I don't even know because I always do this at the top, but I think you could do it down here. I guess you could do like if n is less than 2 or something. You could do that down there. It feels unnatural to me because I'm used to doing it in the convention. So by convention, you handle your edge cases first. And in this case, I think we could do it below the main function logic, but then it's sort of kind of funky because we have to put it before this return, and that kind of like puts it in the middle of the rest of the logic. So for the sake of like consistency and good practice, we put it up front even if we don't need to. There are other scenarios where, like, if I tried to execute this primary, where if I try to do that and I don't handle the edge case first, it's either not going to work at all or it's going to give me like the wrong answer or something, right? And in this case, it's giving me the wrong answer. So in this case, I will handle it first. Well, in all cases, you should handle your edge cases first. So if, what was it? If n is less than 2, less than or equal, no, less than 2, we're just going to return false. We're just going to go straight for false. All we need to do is just return false like that. Cool. And if that's true, then it's going to run this return line here. And if it's not, it's just going to move on. I could put this in an else, something like that, if I wanted to, but this is just sort of an arbitrary nest. I mean, this code is just now nested unnecessarily, so I'm going to get... It's useful for picking up... Oh, cool. Thank you. Somebody said it's useful for picking up the correct result. Go up -1, 0, and the num. Oops. Yeah, it's a little crammed in there, but I think you get the picture. And then just to cap it off. Okay. So I hope that helps y'all understand why oftentimes you'll see like a bunch of conditions sort of front loaded in the function. In this case, we just have this one edge case. Usually, or there's some cases where it's pretty important, and then there's other cases where you just ignore it because, you know, the function will throw an error. Like, for example, what if the function gets a string? So if I print is prime, and I pass it a string of hello, right? So we just gave it, like, this is invalid input. We don't really need to handle this per se in this example, because if we try to run this, like, we want it to break. We want it to say like, hey, you know, a string is not prime. You can't feed this a string. So in this case, it's going to say type error. The less than operator is not supported between instance of stir and int, and that's because actually on line 5, where we're handling the edge case, where we're checking the edge case, n is a string, and it doesn't know how to say if some string is less than a number, because a string is a number, and a number is a number. They're not immediately comparable with a less than operator in Python. It doesn't know how to do that. So it throws an error. So in this case, like, that's actually desirable. You know, like, we want to just get that error. But let's say we did want to do something special. Let's say if n, we'll do if type of n is equal to str, if it's equal to a string, then let's just say n equals the length of the string. And now, so len, the len function, this will take in, it'll take in anything that has a length, which is going to be a string or a tuple or a list. There's ways of doing it with dictionaries and sets as well. And so it'll take in anything that Python says has a length, and it will return an integer representing that length, right? You can't have, you know, it won't return a float. You can't have like 3.8 things in a list. You can have 3 things or 4 things in a list or a collection or a string, right? So it's going to return the length. The length of hello is HELLO. That's 5 characters. So we'll see if the length of this string is a prime number. For the sake of, like, we're checking and handling edge cases, this might be another thing, just a random example. So actually, this first return is this first true is that call. I don't have it done up with the f string, so I don't get the same message in the terminal, but it says true, and we know we passed that 5 because the length of hello is 5, and 5 is a prime number, so that's what we expect. Cool. So that's just another example of handling edge cases. Good. By the way, this is what we're doing here with y'all asking questions. This is the primary, this is the primary purpose of Study Hall, is for you to bring questions in to study the materials and learn. And, you know, we can get some mileage out of that, and that's, I think it can be pretty fun. But the primary purpose is for y'all to bring in the questions and I'll answer them on stream, and we can kind of spitball with them and play around with them and ask questions. Other people can ask questions and chime in. So thank you, and if for whoever's listening, do feel free to keep them coming. This is great. All right. And I'm going to move on, but if you have questions about this one, yeah, you're welcome. Yeah, if you have questions about this one, if anybody has any follow-up questions, I don't mind coming back to it or a new question. So I feel like touching on control flow. We did that a couple streams ago, but we kind of had to gloss over it fairly quickly in the last premium prep class, just because that class covers a lot of material and we just didn't really get to it. So I want to give it a little more airtime and talk about conditions again. So I think we covered this 2 streams ago. These lessons are just talking about if, elif, and else. And these are our if, elif, and else allow us to write code that is going to execute only when something is found to be true, right? So that thing that's either true or false is the condition that controls whether or not some body of code is executed. Okay. So let's look at the anatomy of this. Obviously, we just kind of went over this. We have our if. I'm using just the one conditional keyword here intuitively. If the type of n is equal to a string, or if the value of n is less than 2. So think about the condition as anything that expresses a value, an expression, any expression that expresses a Boolean value, right? Anything that expresses a Boolean value can be used as a condition, right? It is very common to turn things into Boolean expressions with the conditional operators, or the comparison, sometimes called the comparison operators or Boolean operators. I'm going to call them comparison operators because they make a comparison between the thing on the left and the thing on the right. So let's just look at those comparison operators. Now these are really, really common in conditions, but remember, a valid condition is anything that expresses a Boolean value. Any expression that gives back a true or false value is fair game to be used as a condition. Okay. So the comparison operators are going to be equal, equality operator. This is going to check if the thing on the left and the thing on the right are equal. Excuse me. Inequality. Here, well, let me explain this. If the things on the left and the right are equal, then the result of the comparison will be true, right? So if 3 is equal to 3, which hopefully you all know that it is, right? Let's print that 3 equals 3. Let me, we'll just pass right there for now. Yep. There's that one too. Okay. Let me make a little separator here. This is not, semantically necessary. It's just trying to create a separation between the definition part of the code and the execution part of the code. Cool. We'll just push that down for now because we'll come back to that. Okay, so 5, can you guess, is a false statement. So 3 is equal to 3 results in true, 3 is equal to 5 results in false. Not equal is going to be the exclamation point equal operator. So when I combine an exclamation point and an equal sign together like this with no space in between, notice how if I put a space, the syntax highlighting changes, because Python no longer recognizes this as one operator. So they have to be together, smashed together like that. You can have a space before or after or not, although by convention you put a space between these operators. Just it looks prettier than this or this or this. Something like this looks kind of dense. This looks more spread out and nicer to read. Okay, so this is the inequality operator. So if 3 is not equal to 3, is 3 not equal to 3? Is that a true or a false statement? Right? 3 is not equal to 3 is a false statement. 3 is not equal to 5 is a true statement, right? So these are two, I mean, dare I say, the most common, the most versatile comparison operators, because we can use these with any data type. So I can say is hello equal to hi. I can say is hi equal to 5.7. And I can say is true not equal to type of 4 is yeah, well, I think you get the picture. I can use equal to, the equal to operator, or the not equal to operator, equality operator or inequality operator, excuse me, to check across a variety of types. I can check strings, or I can check numbers, blah blah blah. Run that. We get a pile of Boolean values. The last 3 are those other ones. So hello is not equal to hi, so that's false. Hi is not equal to 5.7. It's not even the same type, so that's false. True is not equal to type of 4, which is an integer, so that's true, right? It is true that the Boolean value true is not equal to int, right? Okay, cool. So these are good ones to know. Some other ones are less than or equal, greater than, and greater than or equal. So I'm going to do less than and greater than like this. These are useful for comparing numbers only. You don't compare a string. Actually, we got this error earlier, right? Remember when we got that error that said, let's see if I can find it. Yeah. Type error, less than operator is not supported between instances of type str and int, right? So that error that we got earlier actually kind of stands to my point that I'm making with this. We can say is a number 3 less than 2. So 3 is less than 2 is a false statement, right? Print 4 is greater than 2 is a true statement. Greater than or equal also just includes equality. So we can say is 4 less than or equal to 5, or we could say 4 less than or equal to 4, and that would also be true. If we did 4 less than 4, this would be false, because 4 is not less than 4, it's equal to 4. Print greater than or equal, I mean, hopefully this is implicit, is 5 greater than or equal to 7. I think that's probably pretty self-evident at this point. Okay, so for this, 3 is less than 2. That's false. We should get false. Let's do this. Okay, so I'm going to write my expectations down here and we'll check in the output. False. 4 is greater than 2, true. 4 is less than or equal to 5, true. 4 is less than or equal to 4, that's true. 4 is less than 4, that's false. And 5 is greater than 7, greater than or equal to 7, excuse me. That's also false. So, we expect to see false, true, 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 false, false, if I did my Boolean math right. Ah, you want to see the shortcut commands, eh? Yeah, they're great. I'll talk about a few of those. Well, why don't I talk about them now? Because I'm using them now. I have a feeling y'all just saw me do the multiple cursors thing, and yeah, that's a fun one. So I'll just reconstruct that. So I'm using Atom. We want y'all to use VS Code. It's going to be a little different. The shortcut commands are going to be a little different, but I'll show you how they work for me. I've also customized my key maps like a lot, so I can't say that my keyboard shortcuts are going to be the same as yours, anyways. But I could all of the things that I'm doing are also possible in VS Code. And if you're working out of Replit, Replit uses the same shortcuts as VS Code, and they will be doable in here. Let me know if I say a key command and demonstrate something that doesn't work in Replit, and I will move to Replit and find out how to do it in Replit. No, actually, let's do that now. Replit. Let's just do this in Replit. Log in. Okay. Give me a second. Just finding my my Replit password here. It is important stuff. Yeah, oh God, I mean, the shortcut keys make things so fun. Okay, REPL. I'm finally in REPL. Let's see if I can. Oh gosh. I guess I can put my screen back up. Cool. And y'all can't, right, you can't see this one. Let me just add another scene here. And we'll add a window capture, and that'll be, let's actually scale this down to something that y'all can see. Camera, video capture device, there we go. Hey, I'm back. Cool, that should do. Lock these down. All right, so this is Replit. And let's look at the key commands in here, because these are actually going to be key commands that are going to work in Replit and VS Code. I think they're all going to work in VS Code. I'm like 99% sure, but your mileage may vary. And these are going to be for Mac. So I think it's, what is it, command? No. Okay. I'm not remembering. There we go. So if you want to learn about workspace shortcuts on your own, we're going to do Command K. Command K, that's your big workspace shortcut cheat sheet, right? So here's a few good ones. Find, search. These are more specific for Replit, but if we do, what is it? Duplicate. No, it's not going to show me that one. Okay. Shoot, I thought there was a different one. Okay, sorry about that. Let's copy in this code and we'll write those tests again. So what I'm going to do, I need one of those things that actually shows my keyboard shortcuts in the, or my keyboard commands in the bottom. So let's say I want to put something at the end of all of these lines. What I have to do, I want to have a comment at the end, and like I want to start that comment so I can just kind of go down one by one and do it really quickly without having to like put the comment at the end of the line each time. So all I have to do is find any of these lines, or between all of the lines that I want to be on, right? And so, I mean, the most obvious thing is this print right up here. So what I do is I put my cursor either in the print or I highlight the print, or the thing that's common between all the lines. So I'm just going to put my cursor in it or just around it so it's touching it. And then I'm going to hit Command and D. So Command D. If you're on Linux or Windows, I think it'll be Control D. If you're on Linux, it may be different depending on your distro. But so I'm going to hit Command D, and that'll select whatever pattern my cursor is on. And then I'm going to hit Command D again until I select all. I'm going to keep hitting it. I'm just holding Command and tapping D, D, D until I select all of the things that all of the lines that I want to have my cursor on. So now the cursor is a little bit of a dark color with this background, so hopefully you can see it. But now I have these multiple cursors that I just generated really quickly with my keyboard. Another thing I notice in this case is I have all these ending parentheses, and I don't have any ending parentheses between where I want to start and where I want to stop that aren't in the same spot. So I can just do it on these ending parentheses and then just use my left and right arrow keys to move that cursor around like I would anything else, any other cursor. And then from here, I can just start writing the things that I want to write for all of these lines that say true that need to say false. Okay, so 3 is less than 2, that's false, right? So we can do that. 4 is greater than 2, 4 is less than or equal to 5 is true, 4 is less than or equal to 4 is true, 4 is less than 4 is false. That's that's how you do it. Another really useful one that I use all the time is, what is it? So this is, if I want to duplicate this line and have multiples of these, I'm going to hit Option and Shift, and then either up or down, depending on whether I want the line to be above or below the line I'm on. Right? So if I hit Option, Shift, up, Option, Shift, down. Oops, I hit it 2 times. Option, Shift, up. So if I hit Option, Shift, up, I'm going to get a line below. My cursor is going to stay on the original line. If I hit OptionShift down, I'm going to get a line below, and my cursor is going to go with it, you know? So OptionShift up or down, either one, kind of absolutely all the time. So I would say between those two, that's probably like 90% of the kind of the keyword magic that that you see happening is Command and D to find a pattern to edit multiple lines. And I'll try to say that from now on, just as I do it, and that'll help, hopefully. Okay, cool. So with this one, so we were talking about conditions before, and we were going over the conditional comparison operators, and just talking about how the comparison operators work. So I was just saying the less than and greater than style operators only really work on numbers. I'm showing integers here. Floats are fine as well. You can use floats. I don't think it's necessary to demonstrate that. Let's just make sure it's actually going to output what I said it was going to output. If I did my Boolean math correctly. Oops, did not save it. So I'm expecting false, true, 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 false, false, and I get false, true, 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 false, false. So that matches what I expected. Good. I did Boolean math. Yay. Okay. So these are your comparison operators. These ones are for, again, for numbers, equal to or not equal to, or for anything. You can compare basically anything with it. Okay. So bringing it all back around, back to this whole here's your isPrime function. That's what's happening here. We have our conditional keyword that says we're going to check a condition, and based on whether that condition is true or false, we're going to execute the code when that condition is true. And in other scenarios where if the condition is false, that is the other scenario, we're not going to execute that code. We're going to ignore it. So that's pretty straightforward, right? So sometimes you want to have a condition that's like, let's say we have x equals 5, and we'll say if x is greater than 8, print x is greater than 8. Cool. So if we run this, it's not going to, it's not going to print this out because 5 is less than 8, and that's false, and it's not going to give us anything. So what do we want to do if x is less than 8? Well, we could say if x less than 8, print x is less than 8. There's a better way to do it in this particular case. Excuse me. In this particular case, what we're saying is, given that this previous one was false, we can just say else. And else, so the code under the if executes when the if is true. If the if is not true, if the condition in the if is not true, the code under the else will execute. The code under the else, so notice the else doesn't take a condition after it. It's not checking anything because it is its own condition. Else is like saying, under all other circumstances, just do this instead, right? So if I run this, it's going to say x is less than 8. But what if x equals 8, right? Well, it's going to say if x is greater than 8. If 8 is greater than 8, 8 is not greater than 8, it's equal to 8. So it's going to say x is less than 8, which is actually not true. So this code is just, it's not going to work for 8. So I could add an elif condition and say elif x equals 8. Then we can say x, oops, line duplicate. For me, it's Command Shift down, although that's like I said, this custom shortcut. What was it? OptionShift. And the other one. Okay, so. Oh gosh, I just realized I'm not presenting my text editor. I'm so sorry. I'm so sorry about that. Jeez. Let me just do this. Okay. Make that bigger. I'll make this bigger. Make that smaller. Make this bigger. So you can see I'll have a little secondary replet up here. I'm sorry. I apologize, folks. I was working out of my text editor that whole time, and I was not presenting it. All right. Let me know if you see me doing something silly like that. Yeah. Thank you. Cool. So this is what I was writing before. I had just written this, x. I had this equal to 5. Let me just back it up. I'm doing Command Z just to undo, just to rewind, and we'll just do Command Shift to Z to fast forward. Okay, so I had x equals 5. If x is greater than 8, we're going to say x is greater than 8. And then I gave the example. I could say, what if I want to run or print out that x is less than 8? I can check if x is less than 8. Then I did a line duplicate here, and I pulled that line down. And that's going to tell me x is less than 8. And then I was saying, instead of checking a whole new condition here, we can chain an else. And now these are, if I have a different if, this is a different condition that's always going to be checked, right? So when x is greater than 8, it's going to print this, but then it's actually going to go on and check this line as well, no matter what. But it doesn't need to, so I can say, well, I only actually want you to check this else line if the condition of the preceding if was false. And then, you can run the code under the else if the condition in the initial if was false. So this will work if x is less than or greater than 8, right? But what about if x is equal to 8? Then I can add another conditional keyword called elif, and we'll say x is equal to 8. Okay, and this is where, I think this is where we left off. I'm trying to remember the shortcuts as I use them. I just kind of use them so kind of naturally now. So what I did is a line duplicate. That'll be Option Shift down. And then for me, it's Option down to pull that line with me. Let me try to see what that's going to be in Replit. I think it is. Yes, Option down. Or Alt down, probably if you're on Mac or Windows. Cool. So that will, Option down will just move, Option up or down will just move whatever line your cursor is on with the cursor. So if I do Option down and keep hitting down, it's just going to take that line with me. Option up is going to take that line with the cursor. Cool. Oops. Good. Whew. Back on track. Okay, so now we have this chain of conditions, right? And the thing about this chain, we have an initial condition, an if. So an if starts a new chain, right? A chain can end with that if. It doesn't have to have other links in the chain. It can be only the if on its own. But every if starts a new conditional chain. After the if, you can have an else or an elif, or it can just end. You can have as many elifs in the middle as you want. So I could say elif, let's say type of x is equal to stir. We'll say x is a string, right? We could do that. So I can have as many, if I want to, oh, I just realized I did another sort of shortcut, an iteration real quick on the thing that I've been showing you. Let's see. So I selected these two lines and I did a line duplicate, and that duplicates both of them. So that'll be Alt-Shift down, and then I can alter them as need be. So I can say type x equals stir, and we'll say x is a string. Cool. Okay. Good. So I can have as many elifs in the middle as I want. I can just fill it up with as many elifs as I want, and I don't have to have an else to end it. This conditional chain, like I said, it can end with an if, which just has one if in it. It can have as many elifs consecutively as you need, and it can end with an elif. That's fine. If I have an with anything other than if, so if I just want to like start checking conditions, I can't start with like else check the thing or whatever. I can't start with else. I can't start with elif. I have to start with if, right? I can have elif in the middle, and if I have an else, that necessarily terminates the conditional chain. So that necessarily says, okay, this chain is now done. And if you want to do more conditional checking, you either have to put in more elifs in the middle, or you have to start a new conditional chain at the end, right? So this is useful. This is useful if you have a group of things, like a group of code blocks, and you only want to run one of them, right? This is, you might be saying, well, why wouldn't I just use like if x greater than 8, if x equal to 8, if type x equals string, and if x is less than 8, like why wouldn't you just use consecutive ifs? In this case, I think it would work the same, but let's do something like y equals hello, and then we'll say if len y is less than 2, print short words should be ignored, right? And then we can say if y equals hello, we'll say y is a greeting word. And we could say, let's do this. we'll say fy in this list. Cool. So what I want to do is I want to ignore cases where y is less than 2. Right now, we'll start with y equaling hello. Taking forever to run here. So it says y is a greeting word, right? Inflict arbitrarily and very artificially. So excuse the the obvious lack of logic in my implementation of this, but okay. So it says short words should be ignored, but then it goes on and it checks another condition for y, and it says y is a greeting word, right? So if I only want to run one of these, and let's say I want to ignore all cases where y is less than 3, I can chain these together and I can say, you know what? Only one of these conditions, only one of these, one of these consequence, one of these blocks of code should be run for this whole chain of conditions, right? And in this case, I only have 2 conditions in the chain, but we could pretend we had more. You could pretend we had more and we had a much better example than the one I'm giving. It's the best I could do off the top of my head, I guess. Waiting for the code to run. Okay. So this says short words should be ignored, and I forgot to comment out that previous problem up there. Cool. So short words should be ignored, and even though y is of a state that would make line 35 here true, this is where they're bound together in some way, in the sense that only one of those blocks of code is going to be run when you have an if, elif, else chain, right? If you have an else, it means one of them will be run. It means one of the blocks of code in this chain will always be executed. And the reason for that is else handles literally all other cases. It's just like, okay, if nothing else above it was true, just always do this instead, right? You don't need an else. There's no like convention around like, there's no convention that states you always have to have one. Well, people would argue with me on that. We're kind of getting into a philosophical thing. Some people do say, well, you know, all your conditional, anytime you do any conditional checking, you should end it with an else always. I would just say, don't worry about that. That's sort of getting into sort of more advanced coding paradigm stuff. So if you hear somebody saying that, just ignore it. If you're, I'm just saying, if you're out on the internet somewhere and you're reading something that says all conditional checking should end in else, then just ignore it for now. So some conditional chains end in an else, and some don't need to. That's fine too. Cool. All right. Good. So that's conditions in a nutshell. I'm not seeing any. I'm not seeing this information with perfect comprehension because of my amazing skills as a teacher. But if you do have questions, of course, feel free to ask. Let me cut this out. Okay. Okay, rearranged. So back up to our function here, right? So I was going to use these as an example of if and elif, but I think just doing them with simple information is sort of more straightforward. But in this case, conditions. This is an isPrime function. Its input is a number, or in this case, for some reason, a string, right? The weirdest isPrime function in the world that also handles strings and takes the length of the string, and if it's a string, and we'll ask if the length of the string is prime. Length of n, because n is a string, therefore n has a length, and we'll set it equal to the length of that. So we turn n back into an integer because length always returns an integer. Run or execute or check any of this code, we can just return false right out of the gate, right? And then the rest of this is for divisor and range. Well, this is our primary logic, so we can ignore it for now. Cool. So how could I, or could I, improve this code with elifs or elses? And I'm going to paste this code in Slack so you can just copy paste it real quick, and you can specifically by adding or changing an if to an elif or adding elses or whatever. So I'll give people a couple seconds for that. If you think it should just stay the same, just write stay the same in chat. That's a valid option too. So we can think about that as well. And I know there's sort of a delay, so we'll come back to that. I'll come and check Slack and see what people say in a minute here. So, yeah, I'm trying to think. Oh, now I'm trying to think of something to do. We gotta find something to do for like 2 minutes. We talked about, oh yeah, let's talk about logical operators. That won't take too long. Perfect. All right, multi-line select. I'm just dragging my cursor down. Nothing fancy there. And I'm going to duplicate these. These are little comment blocks that I like to use because I can turn on and off blocks of code really easily, like this. Just using a combination. So still in the domain of checking conditions. We talked about the comparison operators, equal to, not equal to, less than or greater than. We can also check multiple conditions in several ways, and we can also invert the result of a condition, right? So let's say I want to, I gotta think of an actual like tangible example for this, because I do it all the time and I always know when to do it, but I always like I struggle thinking of an actual example for this. So word called not, right? Meaning it gives something back, and specifically it gives back a Boolean value, right? So it also has to see a Boolean value on its right-hand side, in most contexts on its right-hand side. So we can say not 5 greater than 4. So you can think about that, and if you're popping something in chat for the other question, you can put something in chat for this one too. Well, actually, I guess that I'll just say it. The delay is too long. All right. But you can think about, is this going to give us true or false back? You have until I run my code to think about it. Well, I guess until it executes, which is evidently going to be a while. I don't know why it's my Python interpreter just started acting slow one day on this machine, and it's really weird. I don't need it to be fast at the moment, so I haven't really. I've kind of tried to fix it, but I don't know. Apologies for it being so slow. Okay, so the expression 4 is greater than 5 is true. So not 4 is greater than 5 is false, because not true is false. The expression 5 is less than 4 is false. And let's just do this. I'm selecting the thing that I want to replace, and then I'm hitting Command D because I have something selected. I want to select the same thing, and I'm just going to do true, write both of those in, and then write false here. Okay, so not true is going to be false, not false is going to be true. So we can expect this to say 5, excuse me, we can expect not 5 is greater than 4 to be false, because 5 is greater than 4 is true, and not 5 less than 4 is true, because 5 is less than 4 is false. Not true is false. I think I don't have any takers for the previous question in Slack. So we get false, true, false, true. Good. Okay, let's just wrap this up and we'll go back to that question. So we'll leave that in there for now. There are two other conditional keywords. Excuse me, not conditional keywords. There are two other logical operators. I'm getting mixed up. And or. So both of these allow us to check a condition, or check two conditions and do something dynamically based on how whether or not both of them or either of them is true, right? So if I say, let's say I want to run some code, I'll say A equals 5 and B equals 7, and we'll say if A is greater than B and A is greater than 4, then print, I don't know, food. I'm hungry, I think. Okay, we'll just do this. We'll say foo. I'm just being childish. Okay, so, and wow. Oh, hey, I didn't, oh, okay. Anyways, that's not going to run because even though A is greater than 4, because A is 5, A is not greater than B. But we could say if A is less than B and A is greater than 4, we could do that, and that would work as well. Cool. So this whole thing is an expression that's made up of two smaller Boolean expressions. It's a Boolean expression that's made up of two smaller Boolean expressions. So what AND allows us to do is check if both of these expressions are true, then the whole thing will be true. If both of them are false, or either one is false, this whole thing will be false, right? OR is a little different. It's going to allow us to, to execute this code if either of these are true, right? So the only time an OR is going to be false is if both of its operands are false. So we'll say if A is less than B, which it is, and A is greater than we'll do A is greater than 50 here, and we'll say if A is greater than B. So A is not greater than B, nor is it greater than 50, so both of these are false, so this OR would be false as well. So let's just make truth tables for those real quick. So we'll say print true, true. I'll do and here. And then I'll duplicate these again. And for these last four, I'm going to select that and then I'll do Command D until I get all of those, change those to OR. Now I got to change all of these, some of these to true and false and whatnot. So we'll do that one, this one, and this one. Leave those as true. We'll do that one, this one, and this one. And so for this, I'm holding Command and just double clicking all the ones, only the trues that I want to turn to false. If you're looking and wondering how I know which ones to turn to get all the combinations, all the possible combinations, it's because I have done this exact thing and things like it so many times. Cool. All right, nice and regular. Pretty code. So here we'll write whether these are going to be true or false. Start with false. False, and then actually it'll be this one, this one, this one, this one, this one, this one. Okay, not these two. So I over-selected there. So I forgot that these falses would select. I was doing Command D, and I selected some falses that I don't want to change to true. So I can hold Command, and then I'm just going to click on the ones that I wanted to unselect, right? And if I wanted to select them again, I could just double click them. But I'll click them if they're already selected, and that will unselect them. And then these ones need to be true. Okay, so if I did my Boolean math right, we should get false, 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 true, 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 false. And let's actually do this in a new section because so anybody who's studied like formal logic will probably recognize this. Oh, I messed up. There we go. True and true is true. So if you study formal logic, you'll probably recognize these as truth tables. So here's the truth table for OR. Oh, here's another keyboard shortcut. This is just copy and paste, but if you want to copy and paste something, if you want to copy and paste a whole line, your cursor just needs to be on the line you want to copy. And so I don't need to like select this whole line to copy it. I want to copy it, so I'm going to say, I'll just put my cursor anywhere on this line, and I'm going to hit Command C, Control C if you're on Linux or Windows. And then I'm just going to move up to where I want to paste it, and then Command V. I'll say and, right? So this is the truth table for and truth table for or. Okay, so we should get true, false, 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 and true, 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 false. Whew. Okay, let's try that again. Oh, well, I guess that's what we got. This is going to be the same as last time. Good. So those are our truth tables. All right. So let's go back to that question I asked earlier. How could we improve the isPrime function? And admittedly, I kind of gave it away earlier. We only had one taker for a response who said doesn't see any room for improvement to improve it, which is good. I mean, this was a bit of a curveball. It was a bit of a trick question, so no worries if you didn't put in a response, or if you did, whatever, you know. But I just wanted you all to think about this, because this is the kind of thing where I see a lot of people like, okay, well, I should always chain my condition. You know, it's tempting to like want to develop a rule that's like, when I'm writing condition after it, it's a lot like, you should do this because it's convention. But in this case, the logic, you know, the function goes before the form, and therefore there isn't really a form to be followed around this stuff. You have to go by what the logic dictates, whether you have multiple ifs consecutive or it's on the problem, right? In this case, if I did say elif here, right, you might imagine, well, what if we got a string that was like one character long, right? Well, so we'd say if the type of n is a string, which is true, the length of n is actually less than 2, but we're going to return true since we're not handling that in here, right? We can't have a range from 2 to 1. It's going to be like a broken range, and Python's just going to ignore that and not run any of this code. So it's going to move on to this return true, and it's going to return true, but we've already determined that we want this condition, and I actually do want to check it because it still might be relevant to the length of the string passed, right? So I want to be able to handle both of these edge cases rather than handling it as one edge case or end or whatever, branch. Okay, cool. So in this case, with our weird string is prime of a string length function, in this specific case, we want to keep these both as ifs. Where you'll put the body of your code in an else, where that, I tend to think of this as like an aesthetic choice. Like if it feels right to put an else at the end, yeah, okay, do it. If not, then don't. I would say err on the side of don't, because at the end of checking your edge cases, you know, like if you haven't returned something, or, you know, presuming you've made all the adjustments that you need in order to execute the main body of the function, you know, it's just going to move on to this code anyways, so it's kind of a de facto else. And having that else there just arbitrarily nests the code one tab layer deeper. So I tend to be a little against it, but hey, you know, you do you, I guess. Cool. And that's not to say I'm against using else. It's just, I think, in my opinion, it's not necessary here. Great. All right. Yeah. Cool. So it's 5:33 for me in Mountain Time, U.S., of course. And I think this is a good place to wrap up for today. I had fun. This was a good, I like doing these streams. Let me know if the streaming quality is okay. I'm hoping it is. Made some small. We're getting a lot of signal drops before, so hopefully that we can stabilize that. Let me know what you liked or what you hated or how I can improve. Earmarked for or put them in basic prep. And the interaction was really good. I think that's what makes study halls fun, makes them fun for me, and I think it makes them useful for everybody as well. So yeah, so keep the questions coming, and I look for third. Cool. So we'll wrap it up there, and yeah, it was a pleasure. Have a good rest of your day. Bye-bye.